Welcome to section 4.2 on absolute extrema. The goal of this section is to find the absolute extrema of a function of two variables on a closed and bounded region. We'll start by reviewing absolute extrema for functions of a single variable. Recall the extreme value theorem. If f of x is continuous on a closed interval ab, f attains both an absolute minimum and an absolute maximum on ab. The procedure that you would have seen in your first calculus course for finding the absolute extrema of f on a closed interval sometimes is called the closed interval method, and it had these 4 steps. First of all, you needed to verify that f was continuous so that the extreme value theorem applied. Next, you would have found the critical points of f inside the open interval ab. You would have assembled the candidates for absolute extrema. The candidates are the critical points from number 2 and the endpoints. And then you would have found the function values at these candidate points. The lowest value in step 3 is the absolute minimum, and the largest value in step 3 is the absolute maximum of f in the closed interval. Let's apply this in example 4.2.1. We're going to find the absolute extrema of f of x is x times the square root of 4 minus x squared on the closed interval 1, 2. So we're going to note, first of all, that f of x is a root function and therefore is continuous on its domain. And the domain is where f minus, or where 4 minus x squared has to be greater than or equal to 0, which means that minus 2 has to be less than or equal to x is less than or equal to 2. And so since our closed interval is in this domain, f is continuous on the interval 1, 2. And so we can apply the procedure above. So that was step 1. Step 2, let us find the critical points, which means we need to find places where f prime of x equals 0 and where f prime does not exist. So if we calculate the derivative, we're getting the root of 4 minus x squared using the product rule, plus x times 1 over the root, 2 times the root of 4 minus x squared, times chain rule, minus 2x. Those 2's will cancel, and we can clean up by putting this all on a common denominator of root of 4 minus x squared. And in the numerator, we'll get 4 minus x squared, so 4 minus 2 x squared. So f prime equals 0 when the numerator is equal to 0, and that means that x is plus or minus the square root of 2. F prime does not exist when the denominator is equal to 0, which is when x is plus or minus 2. We're looking only in the interval 1 to 2, so we're looking actually in the open interval 1 and 2. So in open 1 to 2, the only critical point that we have is root 2. This is the only critical point in that open interval. Step 3, we're going to assemble the candidates for extrema. The candidates are the 2 endpoints, 1 and 2, and the critical point that we found in the interior. So 1, root 2, and 2. We now, in step 4, evaluate these and find the min and the max. So we're looking x as 1 and root 2 and 2, and we're looking to evaluate f of x. So f of 1 here is going to be 1 times the root of 4 minus 1, so root 3. Root 2 will give us, so x is root 2 times the root of 4 minus root 2 squared is 2. 4 minus 2 is 2, so root 2 times root 2, which is 2. And lastly, if you plug in 2, we get 2 times 4 minus 4, 0. This is our maximum value. This is our minimum value. And so f of x has an absolute min of 0 at x equals 2 and an absolute min max of 2 at x equals root 2 on this closed interval 1 and 2. In the next video, we will see a corresponding procedure for functions of two variables.